Howdy, you guys. If you are watching this video, I am not in class with you today, and I apologize about that. I know we haven't seen each other since last Wednesday. What I went ahead and did is I haven't done it yet. I'm doing it now. I'm going to record your lesson, okay, and I'm going to go through it. If at any point you feel like, okay, Ms. Pena, you're going too fast, just pause it, okay? Or if you need, you know how we take the 2-minute breaks in class and you need that, just pause your video, take your 2-minute break, and then come back to it, okay? So treat it like we're in class. After this lesson, you guys will have an assignment in in Canvas, okay? So it's very important that you pay attention to this today, okay? Because what we're going to do on Friday is going to add to what this lesson is about today, okay? So the first thing we're going to look at, our goal for right now is that we are going to take arithmetic sequences, okay? So remember that from last semester. An arithmetic sequence is a pattern, and the pattern that's happening, like what's happening between each term of that pattern, is addition. Maybe you're adding a 2, maybe you're adding a -2, right? But there's addition going on within a series of numbers, right? And we call those numbers the terms, okay? So we're only dealing with arithmetic right now, not geometric at all. So arithmetic sequences, and we're going to connect that to what we know about linear functions. So a linear function is a function that forms a straight line, right? Linear means straight line. And then we know a function is a relation where every input has only one output. So every x value only has one possible y value, okay? But before we do that, let's look at these 4 equations right here, okay? And you can ignore the paired x stuff down at the bottom because we won't be able to do that, okay? So it says, consider the 4 explicit formulas. So these are explicit formulas for arithmetic sequence, which means we can find any term in the sequence using this formula. And what I want you to do is to think for a second about where is the first term and where is the common difference, right? Those are words we're really familiar with. First term, the first number in the sequence, right? The common difference, that's what's happening. That's your pattern. What are you adding to get to the next term? Is it a positive? Is it a negative? Okay, so I want you to think about that for a second, and I won't give you too long because then you can always pause it if you need more time, okay? All right, so the first term in a sequence comes right after the equal sign, okay? So if you guys see my mouse here, the first term is this 2. The first term is that 2. The first term of a sequence always comes right after the equal sign. If you just looked at the formula, typically we would see a sub 1 right there, and now we see a number. That means that number is the first term of the sequence. So in this equation, the first term is 2. In this equation, the first term is -4. In this equation, the first term is 2. And in this equation, the first term is 4. Okay, so now we got to remember that, right? Now, what's the common difference? Well, the common difference is the number that comes right before the parentheses. So here we have a -4. Well, what does that mean? That means this sequence is going down by 4 each time, right? So we start at 2. The next number is going to get smaller by 4. The next number, smaller by 4, smaller by 4, smaller by 4. And so typically with an arithmetic sequence, we think of that as adding a negative. So we're adding a -4. What about this equation? We're going to add a -2. Positive 2. Positive 2 is our common difference. So that means each term is getting bigger by 2. Right? What about this one? 4. Okay, and I'm going to stop right here for a second. If you are treating this like we're in class and when I'm asking questions, you're answering, it's going to help you try to stay more engaged throughout the lesson and more focused, because I know it's easier to lose focus when I'm not here, right? So try to answer these questions when I'm asking them, okay? All right, What about the fourth equation? What's our common difference? 2 and a plus 2. So that means it's going up 2 every single time. Okay, so you got to remember where your first term is. It's right after the equal sign. And you have to know what your common difference is. Remember, D represents common difference. Okay. All right, so now let's look at it with some graphs. So just to make this a little bit easier, I went ahead and put each graph, and then we were gonna like drag and drop the equations that went with it. I went ahead and did it for you, okay? But I wanna explain it. So how, when I'm looking at this graph, how did I know that this equation worked? Okay, well, let's look. The first term of this graph is -4. First term means your x is 1 and your y would be -4. Second term would be x is 2. Third term would be when x is 3. Fourth term would be when x is 4, right? So I need to go over where x is 1. Why? Because I'm looking for the first term. So x is 1 right here. And it tells me in the equation that the first term is -4. So when x is 1, sure enough, y is -4. Okay, and then the +2, what does that mean? It means we're going to take -4 and we're going to add 2 to get the next term. So when we add 2 to -4, we get -2. Okay, so what does that mean? That means it's going to go on our y-axis. When we go from 1 to 2 on our x-axis and 2 to 3 and 3 to 4 and 4 to 5 and so on, every single time we move over, let me do it right for you, 1 on our x-axis, your y-axis is going to go up 2 because that's the common difference. So this point right here is at -4. And it looks like this one did go up 2. This one went up 2 more, up 2 more, up 2 more. Okay, let's look at another one. Let's look at graph B. So graph B, it says the first term in the equation is a 2. Okay, well, when x is 1, the y value is 2. Okay, good, I like that. All right, and here, the common difference is a -4. Okay. Well, that means it's going to be getting smaller. We're going to be adding a -4 every single time. So from this point to this point, it sure did go down 4 because we're only worried about the y-axis. As long as x is only going over by 1, we're only worried about the y-axis. This point is 4 lower, this one, and this one. Okay. Let's do graph C. In my equation, a sub 1, the first term is a 4. So when x is 1, oops, doesn't look like I did that right. There we go. Y was 2. I should have pretended like I did that on purpose, but I didn't. So when x was 1, y was 2 because the first term of this sequence, I know it from the equation right here, it's a 2. And then every single time our sequence is getting bigger by 4. We're adding 4 every single time. How do I know that? It's right here. It says +4. Okay. And then I'm going to let you look at the last one. All right. Make sure you understand this. You don't necessarily have to know all the details and stuff, but understand, how did I know graph A went with this equation? That's a good place to be right now. Okay. You guys can see this next slide says we're going to take a break. I'm going to keep going. If you need to take a 2-minute break and let that sink in, go for it. Okay. And then I'm going to just keep going, not to waste time on the video. Okay. So did you guys notice anything about those 4 graphs? Let me go back to it so you can see. Each one of those 4 graphs, we have an equation for them, right? and they're arithmetic sequences, but what do you notice about the shape of those graphs? They're all straight lines, right? They're all linear. So every single one of those graphs is linear. So now I'm remembering from last semester, we learned that an arithmetic sequence always makes a linear function. So we get these graphs that are straight lines. So we're not dealing with scatter plots right now, right? All of these graphs make straight lines. Most of them are positive. One of them is negative. I don't care about that right now. But I can see anytime we have an arithmetic sequence, the graph that we get from it is going to be a straight line. Okay. Well, if an arithmetic sequence and a linear function are the same thing, how come their equations don't look alike? Well, let's talk about that. Okay. They kind of have some similarities. So if you have an arithmetic sequence equation, you have a D, a common difference, right? It tells you how it's changing. Okay. In a linear function equation, we always use slope-intercept form, and we have an M. D, common difference, and M, slope, they're the exact same thing. So then what's different? Don't worry about number 2 today, but we're going to look at number 1 on how they're different. In an arithmetic equation, we're given a sub 1. We're given the first term. If we were to write the numbers out as a sequence, we know the first one, right? In a linear function, f of x equals mx plus b. B is not the first term. B, and let me go to a graph so you can visualize it. B is your y-intercept, right? It's where your graph crosses the y-axis. That's not where x is 1. That's not the first term. That's called the 0 term. So an arithmetic equation, arithmetic sequence equation, and a linear function, the common difference and the slope are the same thing. But in an arithmetic sequence equation, we're given the first term, whereas a linear function equation, we're given the 0 term. Okay, let that sink in. If you need to take another break, go for it. And then we're going to start doing some calculations when you're ready. All right. So what we're going to do for this next part, close out of that, is we are going to practice doing some conversions. Okay. I thought I had erased that. Sorry. And this next part, you might need to go back and watch a few times, right? Do that if you need to, okay? But what we have here is we have an equation for an explicit arithmetic sequence. So we have the first term, 2, and we have the common difference, 4. And what our goal is going to be is to take this arithmetic sequence and we're going to rewrite it. We're going to write it as a linear function. So what do I mean by that? So I just said that an arithmetic sequence and a linear function, they're the same thing, right? So why do I have to rewrite it? It's kind of like, think of it as like a makeover. A makeover, you're still the same person. You still are you, but you're just in a different form. Maybe you got your hair dyed. Maybe you got new clothes, right? But you're still the same person. Same thing here. So we're going to take the equation and we're going to turn it into something different. We're going to make it look different. Still the same data, still the same concept. We're just going to put it in a different format. So a linear equation is in the form y equals mx plus b. Okay? Except Instead of y, because we're dealing with a linear function, we're going to use the term f of x. F of x and y are the same thing. They both mean output. Okay, they both mean output. But because we're talking about a linear function, we're going to use f of x. Okay, so here's what we're going to do. In our explicit arithmetic sequence formula, it's a mouthful, I see that plus 4 right there. That's the common difference. That's how that sequence is changing. Remember how I said common difference and slope are the same thing? So if the common difference is 4, the slope is 4. So I'm going to rewrite it, and instead of m, I'm going to plug in 4. Okay, here's where it gets a little tricky, and I feel like it's probably a really common place to make mistakes. So the first term is 2. So can we just plug it in for b? No, because the first term is not the same as b. b is the 0 term. Okay, so let me draw you a little chart, and it might help. So if the first term is 2, and we are adding 4 every single time, that means the second term is 6. The third term is 4, right? But I don't want those. I want the 0 term. I want the term before it. So if the first term is 2, and I'm adding 4 every single time, how do I get the term before it? I subtract 4, right? 2 minus 4 is -2. So if you're trying to get the term after, it tells us to add, but we don't want the term after. We want the term before, so we subtract. Okay. I'm going to show you one more way just to keep it consistent. So now we have that 0 term, and it was a -2. So we can write that in our equation. Okay, so whenever you are looking for b, here's going to be your little formula. You're going to take a sub 1 minus the common difference. Always, always, always. That will always give you b. Take the first term, subtract the common difference. Okay, pause it if you need to. Let it sink in. I'm going to go ahead and start another one. So let's look at one where we have a negative common difference. So our job is to take this explicit arithmetic sequence formula and, convert it into a linear function. Why did I write f of x equals mx plus b? Because that's the format of a linear function. Okay, we got to know that by now. I just know anytime it says linear function, I'm going to make it look like that. Okay, well, we know the common difference is the same thing as the slope. So I'm going to go ahead and plug that in. Okay. You don't have to do the table. I'm just doing it to help a little bit. So the first term of this sequence is 12. When x is 1, y is 12. And every single time it's getting 5 smaller. Okay, we're adding a -5, right? That's how we say it with arithmetic. So if every single time we're adding a -5, if I want the 0 term, I need to subtract a -5. So we're going to take, to get b, we're going to take the first term minus the common difference. Be really careful when you have a negative common difference. It's easy to accidentally forget the minus. 12 minus a -5 is 17. So b is 17. And we're done. We wrote our linear function equation. Okay, we're going to do one more that has a fraction. You all said yay, right? So we have an equation. I'm going to start off with how it needs to look because we're putting it into linear function form, slope-intercept form. The common difference, here we go. Oops, sorry. Uh-oh, I don't know what I did. Okay, my equation went away, so let me rewrite it real quick. And I don't remember if it was plus 1/2 or minus 1/2, so I'm going to go with plus 1/2, okay? All right, so my common difference is 1/2. I know that that's the same thing as slope, so I'm going to come over here and plug it in for slope. But now I need to figure out b. b and the first term are not the same thing. b is our 0 term. It's when x is 0. So to solve for b, you take the first term minus the common difference. Always, always, always. Ooh, but I don't like that. That looks a little strange. Make them both fractions so they match. Okay. And now remember with adding or subtracting fractions, you have to have a common denominator. The lowest common denominator is 2. So I'm going to take that 1 and I'm going to make it match the 2. I'm going to multiply it by 2. But if I do that to the denominator, I have to come up here and do it to the numerator. So I did 12 times 2 to get 24. Now that my denominators match, I just subtract. Now that's an unusual looking b, right? It's a fraction, it's improper. Just leave it like that for today, okay? Whenever we learn something new, I want to focus on the new concept. So 23/2. So you might be saying, well, why is it not 24? Because we're talking about half, but remember, we're not multiplying. Adding half is different than multiplying by half. Okay, so what I want you guys to do is you have an assignment in your WebEx. Let me see if mine will load. And it's in your modules. And it's down at the very bottom. There's a new module, brand new module. And it's called Connecting Arithmetic Sequences in Linear Equations. It's a worksheet that has 6 problems. I did 2 of them for you, so you have some examples with you. You also have the examples we did in class, okay? And I just want you to solve them. Put them from arithmetic sequence format into a linear function format. Okay, we will add on to this on Friday. I'll also spend a little bit of time reviewing just in case you are stuck. If you need me, I will be in my office hours this afternoon, and so we can work on it then. All right.